Hi guys, welcome to the 10.3 video on surface area. And surface area is basically talking about, if you look at the outside of a shape, it's all the areas of the faces of your 3D shape. So there are some quite complicated formulas that you could learn for it, but rather this year we're going to show you just how to add it up by doing a net of a figure. So eventually we'll figure out for like a pyramid or something like that we will just find the area of all 5 faces of this pyramid. So we'll find the triangle, and back 2 triangles there, and then the bottom base that it's sitting on. So we'll find the area of those 5 faces and then add them all together to get the total surface area. But instead of starting with that, let's start with a kind of a higher level question that I want you to really think about. Okay, so imagine these are just 1 inch by 1 inch blocks. So if we look at just the face of one of the blocks, it's 1 inch by 1 inch. So let me get this bigger for you. So we have 1 inch by 1 inch. So this area of this face here would be 1 times 1, which is 1 square inch. So you could ask yourself, well, what's the surface area of just this one block? Well, if we had to think about how many sides there are, think about this as like a dice. And there are 6 sides on a dice, 6 faces on a cube. If each one is a surface area of 1, this would be a surface area of 6. Alright? So what I want you to do now is think about, imagine painting these stairs, the top, all the different sides, the outsides. Sorry, you can't see that. Imagine painting all the sides of this staircase here. So we'd have to include the front, the top, the front, the top, and so on. Also this weird kind of side here, the back side, which you can't see right now. Here's the back side. And then the other side, which is congruent to the other one there. So to find the surface area here, we can actually do that. We just have to count up how many different sides we have. So maybe you can kind of think about that while I find something to write on. Okay. So to find the surface area, we want to kind of break it apart into different things. This is kind of a challenging type question, but it's something good to start with. Alright, so let's kind of break it into different parts. So to find our surface area, what we're going to do is add up all the different sides. So let's start with the staircase. Sorry, the lights are too bright. So to find the surface area, we'll start with the stairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that will be 12 for the stairs. Now we need the right and left side and the back side. So if we count the right and left side, here's the right side. We have 1, 2, 3, 4, 5, 6 on that side. So we can put that in a post-it note. Alright. The other side of the stairs, this is the right side. The left side of the stairs would have 6. And then the only thing we're missing is the back side of the stairs. If you can see that here, I'll show you real quick. The back side, can you count up how many sides there are there? There should be 2 rows of 3, which is 6. Okay. But also for surface area, we got to count the bottom here. So the back here was 6. And if you imagine the bottom here, it was 3 by 3 again. Or sorry, 3 by 2. 1, 2, 3 times 1, 2. So that would be another 6. So the final surface area would be adding those different parts up. So 12, 18, 24, 30, 36. That would be our final surface area. Now, we're not going to do irregular shapes like this for all of these. We're going to work on some different types of shapes. So that was just kind of getting us started. Now, if you can look at your notes, we'll kind of go over a little bit more specifically about certain kinds of shapes. So the first thing we're going to talk about is, what is surface area? Just a kind of a definition for it. So if we write a definition of surface area, basically it represents the total area of all of the faces of any 3D shape. Total area. Remember, area is always in inches squared or centimeters squared or things like that, of all faces. And that faces, it actually includes bases. Bases are included in that too. So all the faces, all the sides, all the outside parts of any 3D shape. Figure. So there's a couple ways to actually go about doing this, but probably the easiest way is to really think about drawing a net of this rectangular prism first. So if you want to jot down to yourself that this is a rectangular prism to remind yourself, that would be good. So what we're going to do is kind of draw the back lines in here so we can see this whole shape. Whenever you're doing this process, there are going to be some shapes that are the same and some shapes that are not. So I'll kind of just draw in a couple right now with a highlighter that are the same. So can you think about which face on this shape would be the exact same as my green one? Okay, the bottom would be exactly the same as the top. The dimensions are 8 by 17 on top and bottom. Now if I get rid of that, could you tell me what shape would be the same as this face, this 6 by 17 side? And that would be the other side, the far left side over here. So there's two 6 by 17 shapes. And then the other one we haven't talked about yet is, don't forget about the front and the back here. So the front and also the back are also the same. Now, a lot of people have trouble finding the dimensions of that, but it's just the top here is 6, and the bottom back here is the same as the front, so there's two 6 by 8s there. So what I'm going to have you do first is actually draw out a quick net of this figure. Let's get those lines back in there. Okay, so to draw a quick net of this figure, here's the 17 by 8. And then what we have is this side's folding down. Oh, sorry. Let's try this a little more specifically. There's the other side folding down. Here we have the other flaps folding down. Sorry, this is really not so good. While you're working on that, I'm going to make it a little better here. Alright, so I can kind of cheat a little bit. If you want to use rulers, you're certainly welcome to. So if we have a couple different sides here, remember there's different ways to make your nets. You don't have to have it exactly the same as mine. You know, these different sides here could go shifted over a little bit, but that would be the net of my figure. So if we label the dimensions here, I won't ask you to do this for every question, but it's good to talk about. This bottom part, 8 by 17, be right here. So I'm going to put those dimensions in there. It would be 17 by 8. The next side we have is this line going up. Kind of the height of our figure there. It's 6 feet. So that height is actually a bunch of different places here. It's actually here, 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 here. Lots of different places. So we basically just have to find the area of these 6 rectangles. And you might have already figured it out, which is awesome. But this 6 happens quite a few places. All right. So we only have 6, 8, and 17. So you basically have to figure out which ones are which here. So the 8 would be the bases here and here. All right. The 6s are here. So we basically can figure out the area of everything. All right, so that if we figured out 8 times 17, that's there and there. So the black parts are 8 by 17. We also have the front and the back parts, 8 by 6s. Those are right here and here. Then the third measurement that we have is 17 times 6, which are the flaps that folded down. So 17 times 6. So if we add all these things together, we'll get the surface area. So go ahead and calculate those distances here, or those areas. I'll get rid of all the extra numbers we don't really need right now. And then you're adding up all those areas. So when I'm going to have you actually do it in class, I'm going to say, there's going to be 6 rectangles. And I do want you to write this down. We had an 8 by 6, another 8 by 6. We had an 8 by 17, an 8 times 17, and we had a 17 times 6. Twice of the 2 of those. So when you add all those numbers up, you can do the math. 8 times 6 is 48. 8 times 17 is 136. And 17 times 6 is 102. When you add all these black numbers up, you'll get your final surface area. And go ahead and check that, but it's when you add it all up, it's 572 square feet. Or the way that we normally write it, feet squared, either one's fine. So that's our final surface area. That's the final answer, adding up all of the sides. So I went a little slowly through that, hopefully to help you with just figuring out all the things that are happening. But we had 6 different faces, so we had 6 different sides that we added together. Okay, 1, 2, 3, 4, 5, and 6. Next shape. My question would be, how many different sides are we going to add together? And this is a triangular prism, so what we would do is we would be adding 5 different sides together. All right? So we're going to have 5 different shapes. We're going to have 2 triangles and 3 rectangles. 2 triangles and 3 rectangles. So I'll do a quick net of this. The bottom base is 12 by 10 and a half. The sides fold down, and those are 7.25 by 12. And then you have your triangles. So let's focus on that triangle. So our triangle is this guy right here. The base is 10 and a half, and the 5 is the height. So we have base and height. And there's a lot of numbers, so you have to be specific about which ones you're really looking at. So the triangle would be 1/2 times 10.5 times 5. We're doing 1/2 times base times height. And that's 2 of them. You can go ahead and calculate those out for me. And then we have 3 rectangles. But notice these 3 rectangles aren't necessarily going to be the same. If it's an equilateral triangle, then they would be. But in this case, we don't have that. It's actually an isosceles triangle. Both of these sides here are 7.25. So you have to look at the back side to bring that measurement up. I don't want to make this drawing too complicated, but kind of erase some of that. So we have a couple rectangles. There's this 12 by 7.25 rectangle. That's the right rectangle, the one that's shaded on the top, if you can see that. I'll get rid of some of this stuff here. So we're looking at this front rectangle was 17 or 7.25 times 12. The rectangle that you can't see that's over here is 7.25 by 12 as well. Sorry. So 17.25 times 12 again. And then the bottom rectangle, if you can see the one that it's sitting on, is 12 times 10.25. I'm sorry, not 10.25, 10.5. So for the rectangles, we did base times height. For the triangles, we did 1/2 base times height. So you can go ahead and calculate all those areas. And when you do that, the triangles end up being 26.25. And some of the rectangles here, remember, they're different, but the 17.25 ones are... Where did I get 17.25 from? Wow, sorry. Let's fix that. There, that 1 needs to go away. It's 7.25 times 12. I don't know where I got 17 from. Sorry about that. But those are 87. And then 12 times 10.5 is 126. Check me on the math there, make sure I'm right. But we're going to add up all these 5 sides. When you add all the 5 sides up, I got 352.5 feet squared. And that's my final answer. Next one. Last one is a pyramid. Okay, I don't know why these numbers are out of order. Sorry about that. But the pyramid, if you look at a net of it, we have a quick little sketch here. We have 4 triangles and 1 square. Let's start with the square. Since this is actually a square pyramid, we have 16 times 16, which is 256, sorry. And then the triangles are actually congruent triangles, which is nice for us. That works out. We only have to do the area of one of the triangles in this case. Now notice I'm giving you the slant height, which means not the height up and down, but it's the height across, or right here, you know, the height of that triangle. It's kind of slanted. That's why they call it the slant height. Go figure. So the base and height of that triangle are 16 times 12. So we'll do 1/2 times 16 times 12. Half times base times height. And it's the same thing for all 4. If you have a rectangular pyramid, they won't all be the same. You'll have 2 pairs. 1/2 times 16 times 12 is 96. So to simplify that, you could do 96 times 4. And then don't forget that 256. If we add all those 5 sides up, even this 256 down there, we get, or at least I got, 640 centimeters squared. And that's the surface area. So today we did prisms and a pyramid. All right. Tomorrow we'll do some cylinders, and those are the harder ones. So tomorrow we'll come in and get some practice with these types of things. It's a lot of different numbers. You got to make sure you're thinking about where they all are in the process there. But thanks for listening, guys, and we'll see you tomorrow.